University of Houston. He has trained and mentored thousands of software developers in US, Canada, Europe, and Asia, and is a regularly invited speaker at several conferences. In fact, I started, this is just a small tidbit that I wanted to share. I met Venkat in 2018 GITS. I was so impressed by his talks that I started giving talks later on. So thank you, sir. Over to you. Yes.
Thank you so much. I really appreciate it. That was thanks for the introduction, but I just learned something about myself today that I did not know, and I'm quite amazed by it. I just realized I've never had vada pav before. And thanks to Satish, I don't think I will ever have one again if I ever think of microservices when it's on the table. So, well, so let's get started. I'm going to hook this up and then we'll be on our way. Thanks for joining. I really appreciate it. It's been a long journey for all of us through these years of being stuck at home or being at home, depending on how you look at it. I spent 3 years in this beautiful place called the basement and with no windows in it. So I'm really happy and delighted to be out and about here. This is my first trip to India since 2019, so I'm really, really happy to be here. So we're going to talk about delegation versus inheritance, somewhat back to the basics, if you will. And it's a topic that we all have heard about, looked at before, but hopefully it gives us an opportunity to rethink about what we do. The best time to ask questions or make comments is anytime you have a question or a comment. So please don't hesitate. Please don't wait till the end. Just raise your voice. As soon as I hear you, I'll yield and listen to you. If you're making a comment or have a question, please do press the green button so that others can hear your questions as well. So with that said, let's get started. So let's talk about inheritance. How many of us like inheritance? Yes, I agree, right? All that money that parents and grandparents especially, right? I don't know about you, but I don't have that kind of inheritance. So, but inheritance is a concept in object-oriented programming. And of course, delegation is also a concept in object-oriented programming. And I want to talk about when should we use which. But I want to borrow a little bit of a title from Satish's talk, the end part to it, not a binary choice. That is something really important to keep in mind because a lot of times we tend to really take this opinion as good and bad. Unfortunately, things don't help us with thinking good and bad. There is better and worse oftentimes. And one of the most challenging things that we do every day is, at the end of the day, context matters. And if we don't think, this is one of the reasons why, if you ask me, there are 2 words I really don't like and I don't use, except when I tell that I don't like it and I don't use, is the words best practices. The problem with best practices is we often tell people, I don't want to think. Here's a checklist. I'm going to just click on it. If something doesn't work, it's not my problem. It's somebody else who wrote it and I just followed it, right? I'm the victim here. So the point really is context always matters. So every single idea that we come up with, we have to ask the question, does it make any sense in this particular scenario? And so when it comes to inheritance, let's talk a little bit about inheritance. So question is, what is inheritance? So we typically have a base class, and also we have a derived class. We also often call it as a superclass, if you will, and maybe what's called a subclass. So essentially, we have 2 classes. And what distinguishes between them is called the discriminator. Discriminator often says, here is how these kinds of subclasses differ from the base classes that we are using. So we talk about inheritance when it comes to using these concepts in object-oriented programming. Then, of course, when it comes to inheritance, what is really inheritance? So you can say inheritance, if you will, stands for, you could say, stands for, a kind of relationship. So kind of relationship, or you can say is a relationship. So what does it really mean, is a relationship? So obviously you would say, for example, dog is an animal, right? Is an animal, is an animal. You could say man is a human, for example. But we got to be careful with this ISA because somebody said Venkat is a pain the other day. That is not inheritance relationship, right? So ISA is right a kind of relationship. That's what we really are talking about, and that's basically what inheritance is really about. On the other hand, we often talk about delegation. Now, this is a source of confusion for a lot of people because the minute you say delegation, somebody says composition. And you're like, what does it really mean? So when it comes to this, one of the things you want to keep in mind is that inheritance, fundamentally, you can say that inheritance is class relationship. So essentially, when I say a class relationship, you're talking about a class or a kind related to another class or another kind. Dogs are animals. That's a class relationship or classification or type information. But on the other hand, you could say fundamentally object relationships as well. So for example, an object may be related to yet another object. And one such relationship is called, as we know, is called the association relationship. So what is really association? Association is where one object is related to another object. So that's basically, for example, you could say, for instance, you could say a company, let's say, hires employees. This is a association, isn't it? Some companies may think that they own the employees and they expect them to work forever and late in the night, not to mention any particular company in the news recently. But the point is, that's not an ownership, that's not a subordinate relationship, usually an equal opportunity in this case. So you could say a company hires employees, you could say it's an association. Then, of course, we also have aggregation. And in this case, it's a part-whole relationship. And essentially, the idea behind this is there is some kind of a ownership, and there is a parent that owns the children or parents that own the part, and you could think about it. For example, you could say car has engine, and that could be an example of aggregation. But on the other hand, something that you could even say a stronger form of association. So fundamentally, you could look at aggregation as a form of association if you want to. It's just that the relationship is a little bit more stronger. If you want to really, really go crazy about it, you could say aggregation is the inheritance from association in terms of that kind of relationship, but I would not go that far. So then, of course, you could talk about composition. So composition is a form of aggregation where the lifetime of the objects, if you will, are tied together. So this is not that interesting anymore as it used to be. Anyone who is very familiar with C++ here? A few of us, reluctantly the hand goes up. It's okay, we're among friends. It's okay to admit that freely. Well, this was a concept back in time. Let's think about why this is exciting. So let's say we have a class called human, and this is a class called human. Oh, by the way, does anyone know if this is Java or C# or C++? It's C++ because there's a semicolon in the end, right? That's how you know. Otherwise, it won't compile. Okay, so anyway, so you have a class human, and you could say, for example, heart, and then you could have a little pointer to the heart, right? So you could say a p heart. So that's a pointer to a heart object. But then you say a brain, and you say there's a brain within this human. Now, in this particular case, you could say this is an aggregation. Why is it aggregation? Because you have a reference or a pointer to a heart. You can swap out the heart. You can even remove it. That's how the person becomes heartless. But on the other hand, brain is embedded. You cannot replace it, even though that will be really useful for some politicians we know, right? So when you look at this object structure, This is where the real concept of composition really comes in here. So if you look at this here, you could say this is actually composition. And the reason it's composition is when you create a human object, the brain is created within, and of course they are inseparable. Their lifetime is tied together. So this is really a concept very interesting and useful in languages like C++. But in languages like Java and C# and almost any other civilized language, this doesn't really matter as much. So conceptually, it could be interesting to think about composition. Practically, it's not of that great importance. But having said that, though, you could say delegation is a way for an object to hand over or delegate. It's part of it, right? So part of its responsibilities, you could say, to another object. That is, well, obviously related to the first object, you could say, by way of association, right? So you could say association, you could in this case say, you could say association, aggregation, or composition. So now you can think about delegation. So delegation is a very simple word, just like you delegate work to somebody else. So that's basically what delegation is really about, right? So is it composition? Well, composition is more of an implementation detail. Whether it's an aggregation or association is more of an implementation detail. But what you're doing is the act of delegating. So you're basically saying, well, I don't want to do all this work. I'm going to take part of my work and give it to this other object for it to function. That's basically what delegation is about. So we talked about inheritance, we talked about delegation, but one of the things I wanted you to think about is this. Which one is more flexible? Let's just think about that for a minute. What is your thought? Inheritance or delegation? Delegation is more flexible. Why is that? Bingo, right? You can change it anytime you want to. Inheritance is, for most part, static. A class inherits from another class, you cannot change it. Well, almost you cannot change it. The minute you say you cannot change it, somebody says, but I can do AOP, right? But then you won't be sane after that. But for most part, you cannot change inheritance, right? For all practical reasons. But on the other hand, delegation you can change. You can delegate to one object now, but you can delegate to a different object later on. So during a lifetime of an object, you cannot change its inheritance, but you can change its delegation. Now, here's another way to think about it. Everybody knows about design patterns, right? We have that for breakfast every day. So which of these two techniques is the most used across design patterns? Do you have more design patterns that use inheritance, or do you have more design patterns that use delegation? So very few design patterns use inheritance. You can count them with the fingers in one hand. If you go back to the famous gang of four design patterns, you have factory method, right? Because factory method says the base class will have a method and the derived class will override it. Factory method. What about abstract factory? Is it using inheritance or delegation? Predominantly delegation, right? So abstract factory is delegation based. Factory method is inheritance based. Template method is another example of a design pattern that uses inheritance. And most design patterns, there's one design pattern that comes in both flavors. Anyone wants to guess what that is? What was that? Bingo, adapter. You have a class adapter, which uses inheritance, and you got object adapter, which uses delegation. So that's one pattern that comes in both flavors. What about strategy? Delegation predominantly. You may look at these patterns and say, wait a second, we are using inheritance, right? So what you want to look for is which is more predominant. Are you predominantly relying on inheritance, or are you predominantly relying on delegation? You will often have both interplay with each other, but which one is the backbone, the fundamental that makes this work? Awesome. You guys are really on top of that. That's wonderful. So the question I want to ask here is, when should we use inheritance? Notice we're not asking, should we use inheritance, right? So we don't want to take sides. We don't want to say right and wrong, do this and don't do that, right? But when to use inheritance? So here is a way to think about it. When it comes to inheritance, you want to really ask the question a little bit differently. So if an object of a class, let's say B, may be used in place of an object of, let's say, class A, then use inheritance. So essentially, let's think about this for a minute. I have a drive function, and drive takes a vehicle that I'm going to pass to a vehicle to the drive, and this driver is going to drive this particular vehicle. So the question is, can this driver, you could say, drive a car, right? So the question you're asking is, can I pass an object, let's say, of car to the drive function? So if the answer is yes, then choose inheritance. So that's basically one way to look at it. So I'll get a little bit deeper into this in a few minutes. But on the other hand, going back to this question, you could ask the question again. And in this case, I would say, if an object, let's say of a class B, wants to use an object of a class A, then use delegation. So essentially, this is where we are saying a little play of words here. You could say to use versus to be used as, delegation versus inheritance. So essentially you ask the question, do you want to use something or do you want to be used as something? So let's think about this a little bit further. Sometimes it's obvious. Sometimes it's not that obvious. And you don't know it's not obvious until somebody tells you that this is plain wrong. And it may be too late. We'll look at some examples of that. But let's say we have a class called eraser. So what does an eraser do? It provides a function called erase, which is going to clear out maybe a board on which you are writing. So an eraser erases, right? Very simple, very easy to see it. So now I say class, a green, let's say eraser. So, pardon me, this is eraser. So I have a green eraser. And what does a green eraser do? Well, it contains a function called erase, and it's going to be also kind on the environment, right? So basically, in this case, a green eraser is kind on the environment. So now the question is, you could ask the question, a green eraser, extend from the eraser. So what's the answer? There is one answer you can give and get away with all the time. What is that? It depends, right? It depends. Except when the spouse says, can we go shopping? No, it depends will get you kicked out. But almost all the time, it depends is a good answer, right? So the question you want to ask is, would we want to pass an instance of a green eraser where an instance of, eraser is expected? If yes, go for inheritance. So let's think about this a little bit further. We have a class called instructor. And guess what the instructor does? Rants away, and you say erase. And you say, look, the board is too cluttered. Can you please erase? Question, should we inherit the instructor from eraser? I hear the laughter in the room because the people who just laughed, others are good. The people who laughed just imagined grabbing the instructor by the collar and wiping the board, right? Sometimes you really come across students who are much bigger than the instructor. They may be tempted to do so, right? But I would say, heck no, right? No, probably not. No instructor would love to be used as an eraser. So this is a concept of where delegation may be useful because an instructor may want to use an eraser to erase. You can tell the instructor to erase, but don't use an instructor as an eraser, right? So essentially, this is a concept where we can get a little bit deeper into this and think about this a little bit further. So the question really is, we can go along this line of inheritance maybe, and we can continue here, but there's always that but, right? But let's think about this for a minute. So we have vehicle, and here's my beautiful inheritance hierarchy, and we have a car that inherits from vehicle. Now I'm going to say, I'm going to inherit an electric car from a vehicle. What do you think? Good idea or maybe not a good idea? Why is it not a good idea? It is? But then why shouldn't I inherit it? From the class car, right? Just as car inherits vehicle, electric car inherits from car. Yes or no? Depends. It depends. And what does it depend on? Good point. So one of the problems in this case is an electric car runs around with parts of a car. That's not going to be really fun. Good point. Any other reasons why this may not be a good idea?
Different functionalities of the car, we need to fuel, the electric car.
That's the problem. You pull up to a gas station and you're trying to refuel. So as a user of a car, if your thinking is that you need to pump gasoline into it, that's not going to go really well with an electric car. So what it comes down to is really implementation. That is something we need to keep in mind, right? So just because, and here is something to think about, right? I travel around almost every week, and which means I rent different cars every week. And with all respect for people who love cars, I just don't care for them. So when I go to the rental car company, they would ask me, what kind of car would you like? Because they want to upsell the cars they can sell me, right? And they would say, what kind of car would you like? And I always tell them this, could you please give me one with 4 wheels? And they would look at me and say, excuse me? I would say, yes, I would really like to have one with 4 wheels, please. Are you serious? You don't care about what you drive? I'm like, I'm very serious. I would rather not be driving, but I can't really help it. So give me one with 4 wheels. And when I get into a car, within about 30 seconds, I can start driving. And you know why? Because the steering wheel is exactly where it is supposed to be. The accelerator is exactly where it's supposed to be. The brakes are where they're supposed to be. Some car manufacturer did not think, hey, would it be nice to swap them? That's not an option, right? Because there's a standards institute that says, here is where these things are supposed to be, and this is the distance between them as well. You cannot say, I'm going to widen this or shorten this, right? You cannot do that. That's the standard. So it takes me 30 seconds to start driving a car and almost the entire week to figure out how to operate the damn radio. Because there's no standard on how we operate radios or the ACs. And just for the sake of records, the worst car humans have ever created, hands down, is PT Cruiser. Anyone has one? Sorry. You had one. That's the right answer. He's a wise man. He had it for 30 seconds, right? The first time and the only time I ever rented a PT Cruiser, I come out to the exit and I'm stopping and I need to open the window so I can give my ID to the person to clear me out. And I'm looking at the window, there is no button to open the window. And I never felt like an idiot as much ever in my life. And I'm like, how do I open this window? There's no buttons, there's nothing to roll down. And the person looks at me and says, look over there. I'm like, why would I look at the next car? And I looked at that side, I looked back, like, I don't know what you're talking about. And she's trying to scream through her lungs, look over there. I'm like, I don't understand. What do you mean, look over there? And then I told her, wait, let me just calm down. And then I said to myself, what's the most illogical thing to do? And I said, somebody has to be really stupid to put a button to open the left window on the right side. I'm like, ta-da, that's exactly what it was. I said, I would never rent this again. What an idiot. But the point really is, you really want to think about one important thing, which is substitutability. So essentially, substitutability, I don't know if I can spell it right. So it takes all my power to spell that word. Okay, so substitutability, so what does that really mean? So this is where we have this beautiful principle called Liskov's substitution. So substitution principle, and so what does this say? Fundamentally, it says a user of a base class should be able to use an instance of a derived class without knowing the difference. So this is what it really comes down to, right? So Barbara Liskov created this wonderful principle, and what she says is a user of a base class should be able to use an instance of a derived class without knowing the difference. So if I have to know the difference between whether I'm given a base or a derived, then the code keeps breaking. Because every time you create a new derived class, I have to change my code because it's not going to work properly. So for this, she goes on to say the services of a derived class should require no more and promise no less than the corresponding, she says, services of the base class. So essentially, if you have a derived class, your derived class services shouldn't require anything more and shouldn't promise anything less. You can require less, you can promise more, but not the other way around, than the corresponding services of the base class. So if you have a certain contract with the base class, a derived class has to really follow that. So going back to this is why, even though your answer earlier that when you have an electric car, it might have to carry around the parts of a car is a good answer, but not a relevant answer. The reason it's not relevant is it comes from the user's point of view, not from the internals. Your internals are encapsulated. Nobody cares, or nobody should care. You can say, gosh, you're wasting memory, you're wasting whatever, right? But that's your problem. But as long as the users of your code, this is why PT Cruisers are not cars, right? Because from a user point of view, it completely is illogical as to where I will find things. And that's the reason he doesn't own one anymore, right? So essentially, substitutability. So the user of a base class should require no more and promise no less than the corresponding services of the base class from the derived class. The user should know the difference. So in a sense, the user should not really know. It should be extremely seamless for them. So substitutability is extremely important. So when to use inheritance? When you really want substitutability. You want to ask the question, do I really want substitutability? So a little corollary from there, what does that mean? Do not force yourself to use inheritance just for reuse of code. This is one of the things we have to be very careful about. It's a slippery slope because the minute you go this direction, what's going to happen? So here's what you're going to get into trouble, right? You have a class called base with the function f1 and f2, or the two functions this class has. You say class, my class, and what do you say? You say, hey, this one needs F1, F2, and F3. So what is the temptation? You simply say extends base, right? You simply do an extends of base. So extends base, and guess what happens? Write F3, and you're done. Isn't that less work? And who doesn't want less work? But this is also known as bad idea. Why is this a bad idea? Well, why did you write this inheritance? So I don't have to write F1 and F2. But what's the consequence of this? Whether you like it or not, anyone who can get access to my class may pass an instance of that class to a place where base is expected. Is that what you really wanted? If the answer is no, you shouldn't go this route. Now, I'm not recommending this, I'm not suggesting this is a great idea, but I love programming languages because programming languages tell us stories about things you can do. Sometimes they're good ideas, sometimes they're bad ideas. But for those of you who raised your hand earlier about knowing C++, in C++ you have a my class, and you really want to reuse the base, but you don't want anyone to ever use a my class where a base is expected. So C++ has this concept called private inheritance. This is a terrible idea, but it's C++. So this is a concept in C++ where you can do what's called a private inheritance. This is pure, I don't know what words to use, violence, right? That's what it is. You can say, when I create my class, I don't need to write F1 and F2 because it gets it from base. But if you take an object of my class and send it to a function that takes a base, the language compiler will say, what are you doing? I can't treat this as a base. And you're like, but I use inheritance. It says, what do you mean? I don't know what you're talking about, right? So this is really a terrible concept because most people didn't understand this properly. It was confusing at the best and really hard to follow. But again, languages kind of explore these kinds of ideas. But that's where they really wanted to use it for reuse, not for substitutability. But in general, though, you really want to think about substitutability when it comes to this. So when to use delegation? Use delegation when your goal is to reuse and you don't care about substitutability. You are saying, look, I want to make this implementation. I don't want to really duplicate all my effort. I'm going to just delegate to this particular object, right? So your goal is reuse of code, not substitutability. That's where delegation makes really good sense. And so a little story about this. A person who I think is a fairly good programmer contacted me and said, hey, Venkat, I've been working on this code. Nothing is working anymore. It keeps failing. Can you help me, please? I said, I'll be glad to take a look at it. And the minute I said it, he said, here you go, the code is yours, and walked away, right? And I'm like, okay, now that the code is on my hand, let me try to see it. And I'm running the code. And guess what? The code compiled, right? And what does it mean when code compiles? It means ship it, right? But he had this naive, opinion, you got to actually test the code before you ship it anyway, right? So he was trying to run the code and it didn't work. It would crash. And I'm just sitting like an idiot, scratching my head. Why doesn't this code work? It compiles fine. When you run it, it crashes. And this was a swing application. And I said to myself, all right, let me try to understand the code. What an idea, right? So I start digging in, and then finally I come to a class where he takes this class and he inherits from like a JPane or something like that. And looking at this inheritance, the compiler didn't complain. And then I'm looking through the code, and there are methods that are private in the base class. He is writing those methods in the derived class. It's not overridable, but he doesn't care, right? Because he decided he's going to use inheritance. And then I started debugging the code. And when you create an object of the derived class, and you pass it to this function, and the function calls a function on the object, It doesn't know to call the function on this object. It calls the one on the base class, which is not the right data type. Boom, everything is blowing up. And it really took me a while to realize, oh my goodness, he's using inheritance when he should be using delegation. And I finally went to him and said, I found the problem. He's like, gosh, that's great. What's the problem? I said, you're an idiot, right? You shouldn't be using inheritance. You should be using delegation in this case. And he's like, at least I know what it is now. Well, the problem is we try to use with vengeance and it doesn't work. So why is it so important to think about? The reason is if you use delegation, your life is easy. I'm using this now, and as you pointed out, I can use something else later. I can change my implementation. It's my business. And it's the E word, right? Encapsulation. Do you need to know that I'm delegating? That's none of your business, right? So I can reuse it. I can change what I do. It's all in my control. The minute you use inheritance, you have to follow this contract. And the contract is your class's behavior has to be consistent with the behavior of the base class. And if you deviate from that contract, you're going to create trouble for everyone who's using your abstraction. Because the user of your abstraction will now have to know the difference. Make sense? Now, this is very obvious, right? But let's think about this obviousness a little bit further.
I have a question.
Yes, please.
Where do you actually place traits? Like we have traits.
Where do we have the state?
Trait.
Traits. Good question. Traits really are a way to, oh, beautiful question. Thank you. I love it. So traits are a way, now you opened up a different talk altogether. I love it. So we'll come back to this talk in a while. Let's deviate from this a little bit and come back to this. So when it comes to inheritance, I love this question, absolutely. There are two kinds of inheritance. This is one of the funny things about what we do in our field. We are extremely tribal. You could program for 30 years and not come across something that is out there in the field, but we never get exposed to. So when it comes to inheritance, Java, C#, C++, keep going, Python, Ruby, Kotlin, Kotlin and Scala, keep going, right? Keep mentioning languages as you go. All of them use what are called class-based inheritance. But there is a special language out there that almost every human fears, and you never mention its name. It's kind of like Voldemort. You know what that is, right? What is it? The one that will not be named, exactly right. And that one, right, uses what's called prototypal inheritance. So prototypal inheritance is a very different form of inheritance. It is still an inheritance. And in this case, what's happening is that you have an object, and the object has a prototype, which contains a prototype, which in turn may contain a prototype, which in turn may contain a prototype until it doesn't. And the way this prototypal inheritance works is pretty remarkable. You go to an object and you ask for a property. If the property exists, you get it. If the property doesn't exist, the implementation under the hood quietly forwards it to the prototype. If the prototype has it, you get it. If it doesn't, it quietly forwards to its own prototype. So in other words, this really comes to what's called stackability. So the stackability is an extremely important concept in this form of inheritance. So it's inheritance not by way of a class inheriting from a class, by way of objects delegating to other objects. So this is inheritance via delegation. So, so going back to your question, what you really have is a trait is a way to implement the stackability to provide a way of mixing. And so really, traits are a way to implement prototypal inheritance in a statically typed language like Scala, for example. So it is related to inheritance, but a different form of inheritance than what we are used to. And so that's where the traits come in. Some languages like Ruby and Python and Groovy provide the concept of mixins, whereas languages like Scala provide traits. I often say traits are more of a statically typed compile time mixin capabilities. So it's a very powerful concept. Mixin is a prototypal inheritance. That's what a mixin is. Stackability is a very key characteristics of mixins. So you're able to bring in multiple flavors into it. Yeah, beautiful question. I love it. I love it. Thank you. Thanks for that. Back to the schedule program. So back to the discussions we've been having, let's talk a little bit about the goods and bads here. So, examples are Liskov substitution principle being used. Let's think of an example. So you have a class, let's say, and you have a class, base class, and in the base class you have a public, let's say F1, and you have a protected, let's say an F1, right? F2. So you have two functions, right? F1 and F2, you have two functions. Now you have a class called derived, which extends from base. Now you know this already, right? You can have public F1, but can you make protected F1? What do you think?
You can reduce the visibility.
So your visibility is generous there.
Here, public you can have, protected you can convert.
You can have it in the reverse, but you cannot have
So would this work or no? No, right? You cannot do this. You cannot. Why not? So the functionality of a derived is less than promise no more, require no more, and promise no less. You're failing on that, isn't it? By the way, that is true with Java. Any C# programmers in the room? Really? It's okay. We really are. Bangalore group is very nice group, right? Satish will vouch for that. It's okay to admit you do use C# once in a while. It's okay. No, nobody really? Oh my goodness. In C#, you cannot change the permission period. Public stays public, protected stays protected, private stays private. That's a requirement of the language. In Java, you can extend it, but you cannot restrict it. Similarly, you cannot say private F2, right? That's not allowed. Or you cannot also say a private F1. That's not allowed either. So you cannot restrict it. You can, enhance it. That's really a Liskov substitution principle right there, isn't it? Okay, let's look at one more example of a good use of this. So I have a base class, let's say in this case, and in the base class, I have, let's say, throws E1, which is some kind of an exception. Now I want to say throws E2, where we can say class E1 extends exception and class E2 extends exception. So let's consider this for a minute. What do you think? Is that okay or not? Will the compiler allow you to do that in Java? Now, don't tell me you don't use Java also, right? What was that? No, right? So this is an error, right? Why is this an error? The exception is not substitutable. Think about this for a minute, right? Let's think about this for a minute. Let's say user receives a base. All right? Now, I'm going to say base.f1. Will this code compile? You can pretty much say no to any code I write, right? It never compiles. But it won't compile. What's missing here? You need to catch an exception or rethrow it, right? So what are you going to do? Try, and what are you going to say here? Catch exception E1, right? With me so far? And what do? You just don't do anything. That's a beautiful tradition in Java, right? So you just write it and don't do anything. No, I'm just kidding. Do something, right? Like what? Print stack trace, which is even worse. But anyway, you handle it. Now you are sitting there and saying, aha, I'm going to say catch E2 exception. What will the compiler do for you? The compiler says, excuse me, what are you doing? I'm going to catch E2. Why? What if it gets thrown? There's a name for this, right? You're like, I'm going to catch everything. What if I'm going to buy insurance? What if the sun falls on my head? I mean, the agents will be happy to sell you that insurance, right? Will the compiler allow you? Yeah, it doesn't, right? Even he sneezes, right? That's clearly not acceptable, right? Compiler says, no, you cannot do this. You cannot catch E2. Why? Because the contract, pardon me, wrong place. The contract of base says you may throw an exception E1, but not an exception E2, right? So the compiler won't allow you to do it. So what are you going to do? You're not going to catch that because it doesn't make sense to catch all possible exceptions. And even worse, imagine you're like, my gosh, I come from this paranoid place. I want to catch everything. But you can only catch what is there. What if you finish compiling the code and somebody comes and writes exception E2? You cannot go back in time and write that code, right? So what's going to happen? Now let's say the compiler allow you to compile this code and run it. And this, for example. So what's going to happen if you pass an object of derived to this code? It comes in here, you call F1, it throws E1, you handle it, everything is good. You call the same function, but this time it throws an exception E2. What's going to happen? It goes above the head, right? Ooh, it's like, whoa, never seen that one before. Where did that come from, right? And the person who wrote the user code feels cheated, right? I didn't expect that exception at all. How did that happen? So the language is protecting us and saying, no, no, you need to follow a contract. Now, this is where it gets a little tricky. A developer says, aha, but class E2 extends E1. What does the compiler do right now? What was that? It scratches its head and asks you, who are your parents? How did they raise you to be like this? Is this a good idea? Why is it not a good idea? Because your intention may be different. And the compiler may not catch the exception. Pardon me, the compiler may catch the exception, but not for the reasons that they expect. So the handling code is going to be messed up. So even though the compiler doesn't stop us, our code reviews should stop us, right? And say, dude, we don't do this around here, right? Don't write code like that. So far, so good? All right. Now, in the JDK, you have a class called vector, right? And you have a class called the stack t extends vector t. This is in the JDK. So it's got to be good, right? Or is it? What do you think? Good, bad, ugly? What do you think? What was that? Oh, I know why you're thinking. It depends on what. Okay, I know why you're struggling. Public. Now, what do you think? Let's think about this for a minute, right? Let's think about this for a minute. So let's say Satish has created a function that receives a vector, right? And what does he do? He takes a vector, he inserts elements, he removes elements, does whatever he wants to do with it. And I and you, let's say, are calling this function and passing a vector. So everybody's happy so far, right? Now I create an object of stack and I send it to his function. And what does he do? He says, oh, stack. And he takes the stack and passes it to Satish's function. And what does Satish do? He says, nice vector. And he inserts elements anywhere he wants to insert, removes element anywhere he wants to remove. And look at him, he's just happy right there, right? He's like, I'm using this vector to my full human right. And I get the stack back on my hands. And I look at the stack and say, how's it going? And the stack says, never do this again to me. Right? What's the problem? This totally violates the invariance of a stack. So what's the invariant of a stack? LIFO, right? LIFO, last in, first out. And what happened to the stack? It says, I have no reasoning anymore. My elements are all jumbled up. I don't know what is first, what is last anymore, right? So it completely got violated on its invariance. Is it a good design? So this is an example of where delegation would have been better than inheritance, isn't it? So instead of this, if we said public class, let's say in this case, stack. And then you say, that's it, right? Private vector store, whatever you want to call it. Can I take an instance of stack now and send it to his function? It says, stop. I'm not going to let you compile the code. Why not? Because I want a vector. You are giving me a stack. I can't do it, right? Now, you say, but wait a minute. What if somebody takes the store? This is why it's encapsulated. That's nobody else's business, right? If somebody breaches through that and passes this, we've got other problems to deal with. This is no longer the problem, right? So essentially the idea is delegation would have been better than inheritance. That's one example. Then the question is, why is it so hard? If that is the right thing to do, why is this so hard? So let's think about this for a minute. Let's say we have a class called worker. So what does a worker do? Contains a method called work, right? So that's all we have. So working. Let's take this for a second, right? Very simple. Now I say class manager, and I want to use delegation. The manager wants to delegate the work to the worker, right? So private worker. And what do I want to do now? I want to say manager, and I create an object of manager, right? And I say manager.work. I want to call the work method. So tempting, right? Extends worker. Go home, right? Done. Now, what's the consequence of this? You can pass a manager where a worker is expected. That's not going to end up too well. So you say, wrong answer, don't do that. So now, what do? Now you say, is equal to new worker, public void work, worker.work. Will that work? What do you think? It'll work, right? What are the consequences? You don't want to substitute? That's good, right? So from the design point of view, right? So from the user of manager, pardon me, user of worker point of view, this is good. LSP, yay. Is that good?
I think manager also works, right? So manager is supposed to be a composite. When I get an employee, employee can be manager, that doesn't work.
Not in this world. Yeah. When was that last time that actually worked? Yeah. So this is great from LSP point of view, right? Because you cannot substitute a manager where a worker is needed. Is that good? What is the consequence of this, though? Is there a downside to this? Did we lose something? Not just one, but two principles. Who wants to take a shot at it? This violates two principles. Tight coupling, yes, but I don't care about that right now.
Delegation is not happening. Is this happening to one worker?
Yeah, but I don't care about that right now, right? But what's the principle we're violating right now? Starts with a D. R. What was that? Well, how is it a dry violation? What does dry principle say? What does dry principle say? Very smart group. You're not repeating yourself. That's good. Duplication of what? Both code and effort, right? Both code and effort. So violates dry. Why is it a violation of dry? Because you got to type that stupid code for every single function you have to route. If this has 4 functions, and if you want to use 3 of them, you got to write 3 functions. And what do you do in the 3 functions? You route it, right? But what has history has shown? Java programmers never write stupid code. They develop IDEs to write stupid code, right? The boss comes out and says, what are you doing? I didn't want to write that code. Good. So what do you do instead? I wrote a framework and the IDE over the weekend, right? This is more expensive now. Why are we solving all this problem? I got a powerful IDE. Why? Because the language doesn't help me in this case. What's the next principle that's being violated? Right? So when you look at code, it's the code that you look at, but it's the principles you need to see, right? So what's happening in that code? It violates, what's that? That's right, open-closed principle. How does it violate the open-closed principle? You modify the worker class up here. Maybe the worker, right? The union got together and they said, dude, hours you're going to work from now on. What's going to happen now? Yeah, the manager is like, okay, fine. 70 hours you work for it. But you got to change the stupid code, right? It's a violation of open-close principle. Because what's happening? So in this case, the problem really is a manager, is never closed for change to the worker. So life sometimes gives you these choices, right? So that you have a nice choice to make. Should you violate LSP or violate both dry and OCP? You got a choice here, right? Should I do this or should I do that? What do you think? You got a choice to make now. Oh, it depends on what. What do you think? What should we do? Should we violate LSP, which is one principle to violate, or should we violate two principles, dry and OCP? What do you think? You're getting there almost. I love where you're going with it. Push it a little bit more. If you violate dry and OCP, that's your problem. If you violate LSP, that becomes an externally visible problem, right? So if you violate LSP, the user's code ends up violating OCP, because every time a new derived class is added, they got to change the code. So now you have a bigger problem on your hand, right? But of course, the ideal situation is when you don't have to violate either one of them. That would be really great, isn't it? Let's see if we can do this. So here is a class called, worker. So what does a worker do? Has a work method, right? And what does a work method do? We'll just print line code at the beach. That's what we do, right? So that's a work method. Let's just say here is new worker and call a work method, make sure it's actually working. And in this particular case, yeah, code at the beach, right? That worked. Now what do we want to do? I have a class called manager. As you would expect, the manager does absolutely nothing. Now I say Bob is equal to new manager, bob.work. I know that's an alien concept for this manager. If you call it, it's going to fail, right? It's like, what do you mean, work? Can't do it. But the manager says over here, worker is equal to new worker. And I simply say delegate. So run the code, it says go to the beach. So you can simply say, I want to just delegate to the worker. Dry and OCP are not violated. Would you agree? How so? How is it that it's not violating the dry principle? Hey, I didn't sit there and keep saying, right, route the call. Didn't have to do it. Now, you go back here, you have an analyze, write a report, right? So what do you do in this case? Right at the beach. Got more work to do, right? I got this report due. You go on and have fun at the beach. I'm going to write this now. And so that's the writer report. So dry and OCP, how so? Bob is very happy. No problem. I can do that for you. Now, take vacation. Bob is not naive, right? Print line, right? Maybe, right? And then you still sneak some computer with you on the vacation, right? So you go to Bob and say, take vacation. And what does Bob say? Bob says, yeah, right. Take vacation. All year long. So run the code, and Bob is very happy because you're the one who's doing the work, right? So notice dry and OCP are not violated. How does this work? The compiler says, hey, when I compile the manager, I will write any method on worker that's not in the manager and do that silly routing for you so you don't have to do it. Seems like an interesting idea. So this is one of the reasons I love programming languages, because programming languages show us things we could do. And of course, in the back of your mind, you're thinking, but But what about me using Java? Delegate is part of waiver. So if you use a project Lombok, you can use tools like that, right? Lombok. And Lombok was created by way of influence from Groovy. What you saw here was Groovy. And the folks who got excited about Groovy said, hey, what if we can do something like that in Java? So they went off and created Project Lombok. So if you're using Project Lombok, you can use the delegate as a feature in Java, for example. So you don't have to duplicate that work. I'm not recommending you should use it. I'm just giving you these options to think about from the language point of view. Becomes exciting, right? So that is delegation the hard way versus the groovy way, and how that becomes pretty interesting, isn't it? But of course, Groovy is a optionally typed language. You can use static typing, you can use dynamic typing, you can go back and forth. And so the question is, can a statically typed language do something like this? This is again why I get excited about programming languages. Because when you think you cannot do something, the designers of the languages say, let me show you how. And you're like, whoa, that's pretty interesting, right? So let's think about Kotlin for a minute to see how that would possibly work. So let's say we have a compute function which takes an integer. And in this case, let's simply return an integer from here. So let's say return n times 2, but let's simply say pretend, right? Pretend this is expensive. So here's an expensive function you're going to call. So compute, and you send a 2 and pretend this is very expensive, right? It's going to take some time to execute that code. So now I'm going to say x equal to 5. And I say if x is greater than 10 and compute of x is greater than 7, and I'm going to put a else, and we will simply print out path 1. Otherwise, I'm going to print out, let's say, path 2. So let's look at the code. What do you think? Will compute be called in this example? Nobody said it depends. I like it. No, why not? What was that? What's the name for that feature? Short circuiting, right? Anyone who doesn't know short circuiting in the room? What is short circuiting? John McCarthy introduced this as part of Lisp. So it's one of the oldest features that exist. You may not know it by the name, but I'm sure you have used it, right? And you've realized it. So what does short circuiting say? If a condition can evaluate the result, you don't have to evaluate the rest of it. That's short circuiting. So if x is greater than 10, no, it's not. Well, it's an and. Why bother evaluating more? It doesn't matter what the result of this computation is. You don't need to evaluate anymore. So ands short circuit on a false, right? And or short circuits on a true. Is that correct? So if you execute that code, it will not execute that part. Compute was not called. We know this, right? But if I said temp is equal to compute x, and I change this to temp, will compute be called? In Java, yes. He's very cautious. Should compute be called? Should it be called? Well, why should it be called? Should it be called? Are you going to, sorry, say that again?
We are not using the temp anywhere.
Yeah, we're not using it. Why should we call it? It's like somebody telling you to do work and you say, I'm done, here's the result, and they throw it in the trash can. You're like, well, why'd you do that? Because I can throw it in the trash can. So what do you do next time? You wait until they really, really are going to use it, right? Lazy. What was that? Sorry, say it again.
What if Kahoot had some side effects?
Ah, but it did have a side effect even before. What happened? See what I'm saying? I'm not disagreeing with you, but that didn't change the fact that it had side effect before. And so the compilers have an interesting way of defining the rules. The compiler says, hey, if it's a short circuit, I won't call it. Okay. What if I write it up earlier, elsewhere? Oh my gosh, what if it had a side effect? I better call it. So they're not consistent. They make up their own rules. By the way, that's a beautiful, beautiful question. I love it. This is where languages are interesting, but one of the things we should, if you're not sure how a language is behaving, what should you do? Google for it. No, what should you do? Oh, is that Stack Overflow? Okay, what should you really do? No, not the documentation. What was that?
Use IDs.
Read the language what? Specification. How many of us have read a language specification? There you go, a few of us, right? Those are the survivors in the room. It's not easy to read language specification, but when in doubt, what do? Read the language specification. If you read the language specification for C++, I know you're laughing. Here's exactly what it says. Even if a constructor were to have side effects, it may not get called. That's in the specification. They knew you. They wrote it for you. So the specification actually says, even if the constructor were to have a side effect, we might not call it. So the answer to the question is, what's the language spec? If the language spec says, if a function may have side effect, we'll call it, that's the rule. So languages can decide whatever they want to do, as long as they put that in the specification, right? That's what counts. And C++ specification says, even if it has a side effect, we have the right not to call it. So in this case, as you can see, it ends up calling it, which is kind of a waste, isn't it? Now you could say, but wait a minute, what if I were to go to the path 1 and I say with, and I'm going to put the temp one more time in here, right? I want to display the temp again. So when I run the code, it called the compute, never used the result, but if I set 15 here, it's going to use the temp, and it says path 1 with 30. So that worked really well. But you're saying, but I don't want to call it. That's a waste, isn't it? You may not see it as such, but you could say, in this case, val temp by lazy. So you could tell the Kotlin compiler, do me a favor, just be a little lazy about it. So what did it do? It said, oh, you want to have temp? Yeah, but not right away. Just be lazy about it. Cool. Let me see if you really use temp. No, you're not using temp. Cool. I'm not going to waste my time calling it. So far, so good. But on the other hand, if you set 15 over here, what's going to happen? It says, I'm going to call it, and I'll give you the value. What did it call it? It called it after, not before, right? So this is after and not before. And guess what? That's another example of delegation. You delegated evaluating that particular variable to a lazy evaluation. It may not appear to be delegation. That's because of a syntax sugar. And if you really stare at this a little bit more, you realize that lazy is a function which takes what? What was that? Lambda. Right? So this again comes to something really exciting. So if you think about it, programming is beautiful for various reasons. But if you ask me, if an award should be given to somebody in computer science, who should it be given to? I got one person for you, hands down. He's a guy named David Wheeler. He was a British computer scientist, and he said something I think is the most profound statement ever, in my opinion. What did he say? He said, in computer science, we can solve almost any problem by using, he didn't say by using a debugger, right? No, by using one more level of indirection. This to me is the most profound statement. By way of using one more level of indirection. Think about that for a minute, right? There is not a day that anyone ever writes code, whether they realize it or not, without relying on that. This is the most profound statement ever, hands down. Why? Think about that for a minute. Procedural programming, level of indirection. Let's think about it, right? So, level of indirection. What is the level of indirection in procedural programming? Like C, passing functions around. What is that? We all have used this. Don't pass that, but instead pass this. What is that? Pointers, that's right. So pointers provide you the level of indirection, right? Isn't that beautiful? You know, I teach part-time at the University of Houston, and this happened last week. A student emailed me a question and said, Venkat, I got this problem, and it's impossible to solve this. That was the email. It's impossible to solve this. And here's the reply I gave to the student. I said, there are two things I always remember. The first thing I remember, this is the email I replied to him. The first thing I remember is, do not confuse your inability with impossibility, right? Because if you say it's impossible, that's it, end of story, shut the light, let's go home. You know, I don't know is a powerful statement. Because when I say I don't know, I feel liberated. There's nothing to hold me back anymore, right? I don't know. And Satish says, let me help you with this. Or he says, I don't know either. And we both start ranting. I say something, he says something, he's like, but why don't you try this? I'm like, oh my gosh. So don't confuse your inability with impossibility. And I told him, the second thing I want you to think about is the words of David Wheeler. In computer science, you can solve almost any problem by using one more level of indirection. I didn't help him. This was my reply to him, right? An hour goes by, and he sends a reply saying, thank you, that was very helpful. And I solved the problem. And I want to show you how I solved it. And I said, cool, how did that work? And he said, when you said this, it just turned on a bulb in my head, that I actually can solve the problem I thought I cannot solve it. So in object-oriented programming, what's that? I mean, if David Wheeler is right, what was that? A little bit more. No, I mean, not a little bit more. I'm repeating it, a little bit more than classes. Bingo. Polymorphism. Isn't that right? What does polymorphism say? Go ahead and call a function on a reference. The function that's called is not based on the type of the reference, but the type of the object at runtime. What's that? Level of indirection. Which means in functional programming, we should have that too. What's that? Lambdas. Beautiful. Lambdas. Lambdas tell you, hey, you can call this one, or you can just hold on to it and pass it to somebody else, or you can call it now, call it later, pass a different lambda. Very, very powerful how we can bring that idea together, right? So when you look at programming, you don't look at code anymore the same way, because when you look at the code, you are not looking at the code, you're seeing these concepts, right? And you're like, whoa, let me see the level of indirection. So when you look at this, don't look at it as a syntax. It's like, oh, we got something called lazy. Tear it apart, dig into it, and say, what's going on here? Why would this work? What's the underpinning behind it? And then you see level of indirection, you see the lambda, you see how those things kind of bring together, which is pretty powerful, isn't it? So let's take a look at one last example of this. So back here, let's say we have an interface called worker, and we have a work method. So our interface, again, Kotlin is a statically typed language. How can a statically typed language provide delegation, in a way that the compiler can be happy as well, is the question. So I have a class called, let's say, manager. Let's start with that first. So, and then I'm going to say in here, Bob equal to new manager. So we create a manager object, and I'm going to say bob.work, and I'll call the work method on the object, right? That's what we want to do. But what if I have a class called programmer, which is going to implement the worker? So the programmer implements worker, which means I'm going to have the override, the function called work, and we simply will say something like code at the beach. Let's start with that first. So let's start with simply worker. So we'll say worker, let's start with that, is equal to programmer, and we're going to say worker dot work, right? Just call the work method on the worker and code at the beach. But I'm going to use the manager object, right? So what can we do here? We can then say, hey, let me take a worker as an object. Somebody was mentioning earlier, your tight coupling. Is the tight coupling now? No, right? Because we have an interface in here. And we can then say in here, worker by worker. So we can ask it to bring in an inheritance of the interface, but route it to a worker at this particular point. So the same by comes in this particular case. And of course, I want to say a val, don't want it to be mutable, and I can call a work method on it. No value passed in for the parameter worker. Yes, of course, thank you. So this is going to be a programmer, right, that I want to pass to this. So now we're using delegation. Again, concepts are pretty much the same, but the implementation is different. And it says, I'm going to take this particular manager, but I'm going to route the calls for the worker interface to the worker instance that's being provided over here. And we are using delegation. This is baked into the language, if you will, by way of the delegation. Versus in the case of Java, we don't have that facility, at least not natively in the language. Groovy uses a compile time AST metaprogramming to do it. But this is the beauty, right? Languages greatly influence each other. Because when somebody pushes the boundary a little bit, it shows the possibilities for what we may have thought as impossible. And immediately somebody else says, whoa, if you can do that, look what I can do. And that's kind of where the innovation begins to happen, right? Where we're pushing the boundaries of the capabilities, and now we got more power on our hand. And in a way, you can think about this as AOP, aspect-oriented programming, right? But it's an aspect-oriented programming controlled by the compiler rather than magic that happens behind the scenes. So it becomes easier to understand, easier to maintain, easier to test, easier to convey the intention, and that becomes very, very powerful. So, simple concept, inheritance delegation, but when you dig deeper into it, it becomes a lot more interesting because all these nuances begin to really appear and can get us really excited. Hope that was useful. That's all I have. Thank you. Thank you. Questions, comments, thoughts, anything? You've been really interactive, so thank you for that, but anything other than what you already asked or talked about? Yes, please.
Why lazy was not a default choice? I mean, why we have to write it because of stack computation? I mean, performance?
So why is lazy not the default? Going back to the excellent point he made, what if your function has side effects, right? So generally speaking, let me let me give you a different answer. It depends. And the reason I say it depends is it is lazy by default in language like Haskell. And the reason it's default in a language like Haskell is because Haskell enforces purity of functions. Functions don't have side effect unless you ask for it. But a lot of times these languages are hybrid languages. They've been evolving over time. So side effect is common for us programmers to use, and languages want to avoid surprises for us. So if they suddenly start not calling and making it default, you are going to be pretty upset about it because the behavior is counter to what you expect. So they're being consistent with our modus of operation, and that's a reason. That's why in language like Haskell, it is default by, it's lazy by default. And I think somebody else had a question or a comment. Yes, please. A little louder, please. If you really think about it, almost any concept is tied to a language. For example, take an example of prototypal inheritance. JavaScript has prototypal inheritance. Lua has prototypal inheritance, but most of the other languages don't. But so think of these as concepts in our field of computer science and implementations provided in different languages. When I was a young graduate student, I remember reading computer science books, and I would read about concepts like mixins. And I would like, wow, this is amazing. I wish I could use it. But the languages that I had access to or the mainstream languages never provided it. Fast forward 30 years later, you suddenly have languages that have these concepts, right? Mixins, I read about it decades ago, but now I can use mixins in Groovy, Scala as traits, Ruby, Python, languages like that. So languages may evolve over time as well. And just like lambdas have been a concept for a long time, but almost lambdas are mainstream today because most languages provide lambdas. So sometimes it may look esoteric, sometimes it may begin to become more popular as time goes on, but these are concepts. If we don't have these concepts, you won't see any implementation. But when you see these concepts, implementations come about. A great example of that is what's happening in Java 19 to Java 21. We have virtual threads. But under that is the concept of continuations and coroutines. If I told you we can do continuations, you would have said, what are you programming in 10 years ago? But today, if I say I'm going to use continuations, you can ask which of the languages you are using. So what was esoteric once is more mainstream today, right? So that's the beauty of it is, concepts evolve, but languages evolve as well. And that's the power that we tend to really benefit from. Other thoughts, other questions? Yes, please.
Hey, Venkat. So I had a question about the last example you gave about Kotlin and how it not breaks the open-close principle. So again, it does delegation by inheritance only, right? So let us say my worker class had a method F1, let us say. And down the line, if my worker class added F1 method, it would be conflicting, right, for my manager class. So totally. In that case, it is violating OCP, right?
Oh, yeah, absolutely. But that's got nothing to do with delegation. That's because of inheritance.
Yeah, true.
Yeah. And keep in mind, you are always going to have this consequence. This is one of the reasons why when you sit down to discuss design, we should never walk away with praises. We should never walk away with biases. Always we have to say, here are the pros, here are the cons. If I cannot see the cons, that means I've drunk the cold Kool-Aid. I'm not going to see what's negative about it, right? If I only can see the negative, that's also a problem. And once we are able to identify these positives and negatives, then we are asking the question, what's a trade-off? Which of among these solutions gives me the least, trouble? That's what you're looking for. So absolutely right. And that's a consequence. And the consequence comes from way of inheritance. And in all fairness, you're going to get into that even when you use delegation, because if a function already exists in the class, but again, right, this is what I love about these thoughts and ideas, right? Because if you go back to this for a second, again, it's unfortunate that nobody wants to admit they do program C# all night and they don't want to let me know about it. But if you have a class, let's say an interface called player, right? And the player interface contains a play method. This is in C#, the methods are uppercase. So now, if I have a class called, let's say, sports person, and in this case, I have a play method. Let's say we already have a play method that's implemented, right? Now, if I come to the sports person and implement a player, maybe just for the fun of it, let's say this is a music player. How about that? Which is the point you made, right? But yes. Guess what? This is a problem in in Java. It's a problem in a lot of languages, but not so in C#. C# says, write a music player.play and keep going. So the language allows you to resolve it. And that's the fun part, right? So you are absolutely correct. And the language says, but here's a way to solve it. Not many languages provide this capability, but C# does. And once again, this is why I fell in love with programming languages is when you see these languages, you're like, whoa, but they solved it this way. And then now you're asking the question, is there a way to do this in Java? And the answer is yes, by using anonymous inner classes. So it takes a little bit more effort, but you find a way to get around it. And that's the beauty of these languages. Languages give you design ideas. And when the languages give you those design ideas, you may move away from the language, but you don't move away from the design ideas. You carry them with you. And now your mind spins ways to implement in other languages, and you're like, if they can do it, I should be able to do it, and then you find a way to implement it. So while you're absolutely correct that it compromises open close principle, there's also a workaround you can implement and get around it, and then you can exercise that. That becomes more exciting, right? So then we are implementing some interesting solutions to implement design ideas in our code. Yep, excellent.
Hi, Venkat. So one of the question which being asked from one of the parties.
Wave at me. Oh, there you are. Awesome. It's easier to listen when I can see the person. Go ahead, please. Yes.
This question actually being asked by one of the participant. So the question is, would Java add the easy way to implement delegation in future?
I don't know. So the answer I say I don't know is two reasons. One is I don't have access to their list of things they want to do. I truly don't. The second thing is it really honestly comes down to priorities. And there are 700 things they can do, which is the most important to do now. And I don't think this is on top of any of those 700 things. So A, I don't know their agenda moving forward, and B is it's not their priority. And I don't think this will be a priority in the large scheme of things. So will it be implemented? Maybe. When? I don't know. I may be retired by then. I don't know.
Thank you.
Yes, please.
Does this work? Lisp gives us a way to write macros, right? That allows us to bake syntax into the language itself. Why don't more languages implement something like that?
Well, the reason really is languages are often created for either solving a particular problem or the language author or authors were compelled to really focus on certain aspects that they consider to be important. And one of the reasons, and the reason I kind of laughed is because we tend to look at languages as, the same, that it's language, I got to program in it. But think about languages as tools. And if you look at languages as tools, there is a screwdriver I want to use, there is a wrench I want to use, and there is a hammer I want to use, but I don't want all of them to be the same. Different things give me a different leverage. And a lot of times when I work in my garage, usually it's because I'm frustrated. Something is broken, I have to fix it, and finding the right tool to fix that particular problem is amazing. I don't want sometimes a general purpose tool that wouldn't solve any of my problems. So languages are like that. Languages are often designed to solve a particular problem or an intent, and that is not their main focus. That's the changes it. Also, compilers are extremely hard to write. I am this happy person who can critique this and say, I don't like this. It can be better. But writing a compiler is enormously complex. Not only that, a compiler may not perform really well, and then we complain, compiler is taking way too much time to compile the code. And even a smallest addition to a syntax may increase the complexity of a compiler enormously. So they want to be minimalistic in what they provide. And certain ideas may be great for certain times and certain applications, may not be really useful for general purpose. So a lot of these complexities come into picture. And as a language user, I'm not capable of really understanding and appreciating all those details almost all the time. But I have to place the trust in the authors of the language to know that they're making the right decisions.
Okay. Nice.
Please. A little bit louder, please. The words, sorry.
To swap a delegated object,
Yep.
is it correct to say that inheritance at some level is always required?
So that's a beautiful question. Oh my gosh, let's step back for a minute. Inheritance is the weakest link in object-oriented programming. This is one of the another reason why I really, really want to program in very, very different languages. If I've programmed in Java, C++, C# to a great extent, I'm of the belief that inheritance is necessary for polymorphism. Languages like Ruby, Python, JavaScript, and to a certain extent languages like C# using dynamic keyword show us that we can have polymorphism without inheritance. So if for a minute, if you separate in your mind polymorphism from inheritance and realize inheritance is not essential for polymorphism, that answers your question differently. Because you can use delegation and enjoy polymorphism without having inheritance.
That's again maintaining the contract, right?
Aha, beautiful. So now we got two different school of thought. Beautiful, right? One is called design by contract, and the other is called design by capability. So this is a fundamental difference in the design approach we take. The design by contract is, I conform to this interface, compiler can verify, and off we go. But the implementation may be broken, violating LSP, Liskov substitution principle. Design by capability is the nature of Python, Groovy, JavaScript, Ruby, almost all dynamic type languages, and when you use dynamic. It's not that they don't have contract, but the contract is much more loose by way of capability than verification. And both are useful. There are times when design by contract is nice because I can get confidence from the compiler telling me things are okay, but I can also write test cases and verify this is actually working, but that gives me more flexibility. I'm not controlled by the contract anymore, which means I can bring in various types and then take TypeScript for a minute. TypeScript has a concept called structural mapping, which is beautiful. Structural mapping says you don't need to implement that interface. As long as the structure of your objects are similar, I will let you pass it by way of proxying an object together. No, it's not duck typing, it's structural mapping. Duck typing is designed by capability, but a structural mapping, still the compiler verifies and says, I'll patch you through. You don't need to tell me you implement that interface, but you have the signature, so I will proxy an interface and pass it through. So in that case, we don't need the design by contract explicitly. It becomes an implicit design by contract. So that can be beneficial too. So is inheritance used often with delegation? Yes. But can I use delegation without inheritance? Absolutely. That's how dynamic type languages work. So it's not a requirement, it's not as essential.
Thank you.
Way back over there. Yes, please.
Yeah. Problem of delegation.
I'm sorry, repeat that for me, please.
Does Go solve the problem of delegation? Like, is it the delegation problem that we see in Java or any other language?
I don't know the answer for that. Don't know. Yeah, please.
So in the beginning, you mentioned that it's not a binary choice, right? Inheritance and delegations can coexist together. So if hypothetical scenario, I'm working on a new class and by some bad design, both the superclass as well as the delegate, they end up implementing one method which gets called by the instance of the base class, sorry, the child class. So how will the resolution happen, or will it not compile at all at that time?
So when I say it's not a binary choice, what I mean is, don't convince yourselves one is right, the other is wrong. When people convince themselves there is a right way, that's where the trick is. That's what I mean by don't have binary choice. But moving away from that, if you have inheritance and you have delegation, a compiler might give you errors in certain situations when it can find the conflict. Okay. For example, in languages like Kotlin, if you try to override a function but you don't say override, it's going to give you an error for that, right? So it depends on the compiler. There's no universal check you can rely upon. This actually gets a little more interesting and deeper as well, because some languages give you multi-methods. So you can override different methods and overload at the same time, whereas some languages, a lot of languages don't provide it. So there's no universal answer to that question, right? It depends on the compiler and how the language implements it. But more important answer is we need to learn the semantics.
Yeah, I mean, right? Hypothetical scenario, if it's by various factors, it came into a bad design. So
but the reason is two things. Okay, now we need to really be good at. One is we need to understand the semantics. We need to have a good command on it. And then we need to be able to evaluate the pros and cons.
Got it.
And sometimes it might look a little weird, but there may be a good reason to do it, and we need to be able to support it. So that's important to be able to consider that in evaluating and decide whether it's the right thing to do or not. So it might really be a good design, or it may not be, depending on the context, and we have to evaluate it.
Thanks.
I don't know if you're going to get to that kind of capability in Java. I'm not sure if that's going to happen anytime soon. C# has dynamic, Scala has dynamic. I don't think Java is going to do that anytime soon. I'll be surprised if that happens. Yes, please.
Hi, it's really amazing to hear a talk from a polyglot like you, and you've kind of taken that level of indirection one level higher, where you're talking about different languages and like seeing the design patterns or seeing the ideas or the concepts in different languages. Doesn't that make it very hard when doesn't it lead to an analysis paralysis while choosing which direction to go in, and how do you go about solving that in practical terms?
Yeah, that's actually a really interesting question. It feels liberated when you realize there is no one right way to do, right? To me, that's the most important thing, is to not go home thinking this is the only way to do. It's very humbling when you know that there are different ways, and even more humbling that there are ways I don't know, which means that I need to be open about it, right? So that there are other solutions we may explore and learn as we move along. But then, knowing that there are so many options is good, but given a particular situation, you want to be able to narrow down to your choices. And that's where the evaluation of the trade-offs comes in, as he pointed out earlier, right? It's like, if you do this, here's benefit, but here's what you lose. And you can more so do a process of elimination rather than process of selection. Process of elimination is a very powerful approach. Rather than asking what all can I use, if I ask what all can I discard, that happens very quickly. So then your choices dwindle down pretty quickly. And then it becomes a lot more easier to settle down. But at the same time, I'm a huge fan of this one particular, again, these are things I try to remind myself a lot. And that is, essentially to say, make it work, make it better real soon. So the answer to your question is time box your efforts. So when I run into an analysis paralysis, I'll tell myself, okay, this is great to have all these choices, but you got 15 minutes. Pick one, and you have the ability to come back and improve it. But I got to move on right now because my customers are waiting on my solution. I cannot tell them, I want to find the best answer for you because they need to, again, it's a trade-off, right? So a lot of times, the need to deliver takes priority and all the other things fall into that. So, and also the beauty is I can always come back and improve it. I can change it. I can make it better. And to us, that's one of the biggest strengths we have in our field is that when we take a second pass at it or a third pass at it, we're no longer the same person reading the code. We are at a different elevation. And so we can apply different solutions to problems as well. And then honestly, that's very humbling and rewarding at the same time is because you can give a second coat of paint, so to say, right? And make it better. And knowing that you can do it doesn't stop you from making progress right now. But you're right. There are times when people end up with this analysis paralysis. But I also would say that's when the power of having other people around us, when somebody pairs with me, they kind of say, good job, but we got to move on, right? So let's pick a solution. Let's talk about pros and cons and move on. So they bring you down to the reality at that point. Sometimes it's yourself. Sometimes it could be somebody else.
Thank you so much.
Yeah, even your laptop is saying that give me rest. We can have the question afterwards. We have some snacks and tea coffee.
And don't be lazy about it.
I mean, good for the others if you are lazy.
Very good. Thank you.
Thanks a lot. Let's hold on for a minute.
Oh, yes. Do you